Hello folks, and welcome to the channel, or welcome back. And those of you that have not seen the video before on the VEVOR stud welder and all the troubles we had with it, this is the continuation after I turned in a complaint to VEVOR. There were two major problems with the VEVOR stud welder. The first issue we ran into was that the side electrodes were not of the same length. So as a result, the gun was in an angle on the piece of metal, and that resulted in the stud nail to be welded under an angle. Now that was easy to fix. I grinded off these two studs a little bit, so now they're of equal length. Now that should work better. However, the middle part is still a little bit flimsy, but that hopefully will work. The second issue was that it didn't have enough power to weld on the stud nails or any of the other washers that came with the tool. We tried different settings on the power level, so a longer duration. We also tried for the different studs, so a stud nail, a stud washer, and so on. We tried all this, and in fact we even tried to use the spot welding mode, which is mode number 5 at maximum power. And all that didn't work properly. It was just one big misery. So I turned in a complaint. Now I raised a trouble ticket with VEVOR. As you can see, I have a whole bunch of conversations with VEVOR. Unfortunately, that is all in Flemish. And at the end, I got actually a trouble ticket from them, whereby they agreed to replace a part of that, which is kind of interesting. So I'm not going to go through all these mails, but basically they were telling me, right, we'll ship you a replacement part. And I don't think that should be the case, because they should have shipped me a proper device and not just a replacement part. And you can see there were many mails related to this and conversations. And 5 days later, I received the package. And it came in from Shanghai, as you can see. So I was quite pleased with the fact that they were able to ship things out to me that quick. So this must have been a known problem. So what they shipped to me was a new controller or motherboard. And this is our new motherboard. And according to them, this is going to provide more power for the stud welder. I kind of believe it, because I noticed that they have a bigger triac on it. And we'll check out what the ratings are on that triac. But I think this is at least an 80 amps triac, based on the data sheet that I found. So yes, this might provide more power, but we'll see. But for the rest, this looks very similar. The only worry I have with this bigger triac as is on here is that there's no cooling fin on it, and also the transformer may run into problems. But I will give them the benefit of the doubt and we'll see. I have prepared two pieces of metal, a thick one which is about 1 millimeter, and then a thinner panel which is about 1/2 mil, which is typically used on the bodywork of a car. I divided it in two parts. I call it new and old. So I'm going to weld some of those studs onto these two panels with the old motherboard, and then we do the same thing with the new motherboard, and we'll see what the difference is. So we're going to try to weld on a thin and a thick stud nail at the stud nail position number 1 at maximum duration for that stud nail, and see how that goes. And then finally we're going to go to position number 4, where we're going to weld on this wavy wire onto the metal and see how well that is holding up. But first of all, let's start welding up the old stuff. I'm going to start with the thick stud. Let's see. And now we're going to try the thinner stud. Alright, so we got those two on. I'm not going to break them off yet. And now we'll do the same thing on this little piece of metal here. The thin stud nail. We need to make sure we have good contact. do the thicker one. All right. Now it's time for the wavy wire, so I need to put another attachment up. And let's see how that goes. Okay. So we got a couple of welds on. I'm going to redo one. Okay. So this part now is welded on. I changed the head to spot welding. And I put it to the right position, maximum power. Let's see what that does. It's a little mark. The two stud nails welded on, 1 and 2, the thin one and the thick one, and it looks like they kind of marked all right. And then the bottom one is the mark from the spot weld. So now let's see what it does with the new motherboard inside. And therefore we're going to take the old one apart. I've done that before, so that should not be much of a surprise to do it, just a couple of screws. So let me do this and I'll show you once I'm done how it looks at the inside, and you might have seen it from my previous video. Now there's a flat cable attached, but here is the old board, as you can see. So now I just need to disconnect all these cables and we should be good to go. Okay, and then one more cable. This might be a little bit more difficult. Typical, these ribbon cables are tight. Okay, and it's 2 of them. All right. So here we have the two motherboards or controllers next to each other. The one that I received by mail with the bigger triac on it, and the one that was originally in it. And you can see the difference on the triac. This one is probably far more powerful than this one. So I'm going to look this one up on the data sheet and find out what it is, and then we can compare the two. And then we're going to swap over the motherboard. I might, if possible, move over the heat panel here. This is specifically a heat shield, which is used to cool down these triacs. I don't know why they didn't put one up on the other one. No idea. Probably they figured out you don't need it, but typically it's a good thing to have that. I have looked up the original motherboard, the triac that's on there, and it's a MOSFET. And that is a BTA 41006B, and it can drive 40 amps. I also looked up the second motherboard we got, which is supposed to be far more powerful, and that is driven by a BTA triac 80. And you can see that our current here, the average on-state current, is 80 amps, so that is the double. So we should have more power. I'm going to remove the cooling fin from the back of the original one, because I don't know why they did not install it on the other one. It's a bit weird. So they kind of soldered the heatsink on the PCB with those two pins here. I'm not going to worry about it right now. I will move it on later if it works with the bigger triac. Now if the replacement motherboard works fine, I will certainly take off the heatsink and stick it back on the second board, and I will use the silicon heat transfer compound. Going to install this panel with all its connectors. And where are they? Here they are. This is the first one we need to put up. That's number 1. We also need to connect up the white one. But let me wait for that. Let me do the flat ribbons first. Sorry guys, this will be a little bit in your way. Now it's correct. Now we stick the second one up. Now that will be better. Okay, now we're getting there. Okay. All right. Yes. Finally, this was a bit of fiddling, guys. I got it reassembled, and just to show you, the old PCB is still out, so the new one is in, just so you see that I did not cheat. I'm going to power it on. I haven't tried it. I don't know what's going to happen. I mean, for all what I know, it catches fire or whatever, it explodes, I don't know. But let's see. So I'm going to plug it in now. And so far, I did not see anything happening. I got my LEDs on. Can I change them? Yeah, I can. All right. And can I select those? Yes, I can. So I'm going to set it back to stud nails and the longest duration. So we're going to start with welding up on the new side a thick stud nail. And the settings are longest duration stud nail. Let's see how that goes. If it goes, right? That seemed to have made a difference. Now let's do the thin one. It felt like it had more power to it. And it certainly does. So we start with a thick one. Oh yeah, you can see the difference. This is a lot better. Alright, so let's have a look. What we can see is that the new control board provides a much better penetration and welding of the stud nail onto the panel. You can see that circle around it. Compare that to the old one and the circle is a lot less. So these are much better welded on. I will try to pull them off in a second. So now let's put up another wavy form, which is the new one. The one which is bent is the old one. And I'm going to set it to the right position, which is the wavy wire. Now we go max power, just to see how it goes. Oh yes, this is remarkable better, but the tip still falls out. Not that it matters much because I can put that one in later. And I'm just going to do a second one on this one. Yeah, we're a little bit off the side here, but this seems to be a lot better. All right, now forget the tip that's falling off. That doesn't matter really. Right, so now let's try the spot weld. So I'm going to put it to spot weld, maximum duration, and here is the tip for that, and let's see what this guy is going to do. All right, that does make a lot of difference, but again, the spot weld is not intended to spot up metal panels, it's to flatten out the little unevenness that you have once you remove the stud nail. So now let's see how strong these stud nails are. Let's give it a try, and I need to hold it. Oh, this is tough. This is tough. That's tough to get off. Now let's look at the old one. Oh, that came off. And that came off. Now you can actually see how much the weld was. So with the new powerful triac inside, it is working a hell of a lot better, and it's actually doing what it's supposed to do. Let's see. Let's try. Let's see how it is on the thicker metal. It's fairly tough. Okay, oh, this is easy. So the old one was much easier to pull off than the new one. The new one was reasonable okay. You can also see that the spot where it's been welded is bigger than on the old one. So this is working just fine. Now let's look on the wavy wire. Guys, I'm so sorry I forgot to turn on the recording on the camera while I took the wavy wire off. But this was the wavy wire that we had on there, and you can see the 3 areas where we welded it onto the thick metal, and you can see the spots where it was. That lines up with that. This was fairly tough to get off. I really had to pull on it. This is the wavy wire that was welded onto the part with the old motherboard, and you can see we barely have any spots there. This is where it was. We have a little spot, a little one, and a little one. You can see that compared to those, there's a big difference. And this came off fairly easy. Now, the idea of the spot welder is not to spot weld metal together, but once you remove these stud nails, there's an unevenness here. You can feel that. That's where it was welded. And with the spot welder, you should be able to push this down again. So I'm going to give that a try and see. Okay. Yeah, it makes a difference. It's been pushed in. So the little unevenness has been removed. Now for the heck of it, let's try to weld on one of those washers that came with it. That was a big flop before, so we need to put this special attachment up and then see how that is gonna go. This is the part that often fell off, if you might remember. All right. So I'm gonna set it up for the washers, which is position number 2, I think. Okay. Now this is looking and feeling a lot better even on thick material. So now let's try it on the thin panel and see how that goes. Okay. I probably burned a hole in my table. Let's have a look. And that came through nicely. So let's see how easy it is to get it off. It's hot still. Alright, and it's a nice little burn. You can also see it here on the washer itself. Now let's try it on the thick panel. And this was welded on pretty much alright. Yeah, you see good burns, good marks. So that works. So folks, my end conclusion is that the uprated motherboard does weld a lot better. It appears to be welding very well the stud nails, the wavy wire, and even the washers, even on thick and thinner material. So I think that's quite all right. Now you can ask yourself the question, is this something that the customer should change? Probably not. I don't mind doing it because I'm an electronics engineer by profession, so I kind of know what I'm doing. But I would suspect that VEVOR would upgrade all these devices to the proper triac inside, so you have more power, because it was really underrated. I don't know why they didn't check on that before. Anyhow, so after I have corrected the head and making the two electrodes of the same length, after I changed the motherboard out with a more powerful triac, this is now working reasonable. I still will open it up again to put the heatsink up onto that motherboard, which I have not done so far. But nevertheless, it still stays a very fragile piece of kit. The plastic is, as I said before in my previous episode, very brittle, and in fact, I already have a small crack here. So if you drop this, it's a problem. Now this was 200 euros with a lot of pieces in it, so it's not too bad. But then again, I don't think it's right that you as a customer have to fix it like this. It should be fixed by the factory from the start, and they should have shipped me a brand new one which was already upgraded. So thank you for viewing, and I'll see you in my next video. Bye bye.